The graph of a polynomial function is smooth. That just means it has no sharp corners or cusps. And it's also continuous. And that means there's no holes or gaps. So this means that we could draw without lifting our pencil. We would never have to lift our pencil if we were to trace our polynomial function. Here's some examples of polynomial functions on the left. So we have our quadratic function in green here. If we were to trace this function, we'd never have to lift our pencil. And it's smooth and it's continuous. The graph in red is a cubic function. If we were to trace this function, we never have to lift our pencil, and it's smooth and continuous. All these turns have smooth turns. And then p of x, which is in orange, is what we call a quartic function, or a polynomial of degree 4. And once again, if we were to trace this function, you would see that we never have to lift our pencil, and every turn that we take is smooth. On the right, we have some examples that are not polynomial functions. From our parent function group, we have the absolute value function, k of x here. And here's the trouble with this particular function. It does have x to the first degree, but the absolute value of x, that function, has a sharp turn. It has a corner. So that is not a polynomial function. And we already saw in the first video that rational exponents are not polynomial functions, and their graphs show you that they're not because they have what's called a cusp, or this one in particular does. And then we have a piecewise function, j of x, the purple function here. It has both a gap and a hole. So we would have to lift our pencil to trace this graph. So this piecewise function is not a polynomial function either.